Hello everyone, I'm Professor Sahebgouda Patil, Department of Computer Science and Engineering, BLDEACET in Jaipur. So I welcome you all for this cloud computing lecture. So in this lecture, I'll be teaching the following content. Let us see the content now. So in this lecture, I'll be focusing on the virtual machine monitor. We popularly now call it as a PMM. That is virtual machine monitor. Then in detail about virtual machine. There are like different virtual machines are there. So we'll see with the pictorial representation how each virtual machine that works. That these two topics we'll see in the today's lecture. First, we'll see virtual machine monitor. That is VMM. What do you mean by virtual machine monitor? A virtual machine monitor is also called a hypervisor. Okay, so it is also called what? Hypervisor. A virtual machine monitor, it is also called as a hypervisor. Virtual machine monitor is a software. Okay, remember, virtual machine monitor is what? It is a software. It is a software. Yes, it is a software. What it does, that securely partitions the resources of a computer system. The main job of this is which partitions the resources of a computer system into one or more virtual machine. So this is called as a hypervisor. The role of hypervisor is what? Partitions the resources of a computer system into one or more virtual machine. Next, we can see guest operating system. So what do you mean by guest operating system? Guest operating system is an operating system that runs under the control of virtual machine monitor. So this will runs under the control of what? VMM. Under the control of VMM, that is virtual machine monitor, rather than directly run on the hardware. So guest operating system, what it does, instead of directly run on the hardware, so which runs under the control of virtual machine monitor. The virtual machine monitor runs in kernel mode, where we have seen two kinds of modes. One is kernel mode, another one is user mode, isn't it? Okay, so this virtual machine monitor which runs in kernel mode, whereas guest operating system which runs in user mode. Okay, sometimes the hardware supports a third mode of execution for the guest operating system. Apart from this, we can see the more about virtual machine monitor. That is, virtual machine monitor allows several operating systems to run concurrently on a single hardware platform. At the same time, virtual machine monitor enforces isolation. So this is very important, which enforces isolation. Why? Because why it enforces isolation among the system? Because to enhance the security, so virtual machine manager, what it does, it enhance the isolation. It enforces the isolation to enhance the security among the system. So apart from this, virtual machine monitor, which enables the following. So what are those? The first one, that is multiple services to share the same platform. Virtual machine monitor, which allows multiple services to share the same platform. Next, it allows live migration. So what do you mean by live migration? Live migration means the movement of server. Okay, what is this? The movement of server from one platform to another. Okay, from what? From one platform to another. It is called as a live migration. Okay, hope you understood this. Live migration means what? Live migration means the movement of a server from one platform to another. It is called as a live migration. Apart from this, virtual machine monitor, which also allows system modification while maintaining backward compatibility with the original system. Next, the virtual machine monitor, which enforces the isolation among the system, as I told you, to provide the security. So this is the important concept which is relevant to the virtual machine monitor. Okay, so virtual machine monitor virtualizes the CPU and the memory. How it will virtualizes the CPU and the memory, that we can see. What happens when a guest operating system attempts to execute privileged instruction? When it attempts to execute what? Privileged instruction, the virtual machine monitor traps the privileged instruction. What it does, it traps the privileged instruction and operations and enforces the correctness and safety of the operation. So the main cause of this is enforces what? Correctness and safety of the operation. This is one of the advantages of the virtual machine monitor. Apart from this, the virtual machine monitor guarantees the isolation of the individual virtual machine. So the individual, it guarantees isolation of the individual virtual machine, thus enhancing the security and encapsulation. Encapsulation is nothing but the hiding the data. Okay, a major concern in the cloud computing. Encapsulation and provide enhancing the security to the data in cloud computing, that is done by what? Virtual machine monitor. So next we have, as I told you, it traps the interrupts and dispatches from the individual guest operating system. So it also controls the virtual memory management. So here we can see the importance of the shadow page table. So what is a shadow page table? The virtual machine monitor maintains a shadow page table, okay, where for each guest OS, okay, this is for what? Guest operating system. For each guest OS, and replicates any modification made by the guest OS in its own shadow page table. So each guest OS having the shadow page table. So the replication, whatever it is done or any modification made by the guest OS in its own shadow page table. This shadow page table points to the actual page frame. What it does, it points to the actual page frame, actual page of frame, and is used by the hardware component. That hardware component is called as a memory management unit. So the hardware component that is used by for this framing the page frame, actual page frame, this is called as a memory management unit. Okay, then we can see the memory virtualization as well. So what happens? The memory virtualization has important implications on the performance. So what kind of performance? It is all about the system performance. Okay. So VMM use a range of optimization technique. The example I can say VMware. Okay. So VMWARE. So VMware, it is a system. Okay. So which avoid page duplication. What it does, VMware, it avoid the page duplication. So we need to avoid this page duplication. Why? Because we need to save the memory, isn't it? Okay, page duplication among different virtual machines. They maintain only one copy of shared page and use copy on write policies, whereas Xen imposes total isolation. Zen is another virtual machine. VMware is one example. Zen is another example. Whereas Zen imposes total isolation on the virtual machine and does not allow page sharing. Where Zen, it does not allow page sharing. Does not allow page sharing. Okay. So this is all about virtual machine monitors. Hope you have understood this. Move on to the second important concept, that is virtual machines. So first we'll see, okay, what do you mean by virtual machine? So virtual machine, it is nothing but it is an isolated environment. Virtual machine is an isolated environment that appears to be whole computer. What is this? It is an isolated environment that appears to be whole computer, but actually only has access to portion of the computer resources. Though it appears to be whole computer, but it actually accesses the portion of the computer resources. So this is what virtual machine. So each virtual machine appears to be running on the hardware, giving the appearance of multiple instances of the same computer, though all are supported by a single physical system. So all are supported by what? Single physical system. So here we have the kinds of virtual machines. So that is the first one, process virtual machine. Okay. So we discuss like mainly two kinds of virtual machine, that is process and system virtual machine. Just look at here. First one, process virtual machine. So what do you mean by this process virtual machine? Process virtual machine is a virtual platform. Of course, it is a virtual platform created for an individual process. Remember this, process virtual machine, which is created for individual process and destroyed once the process terminates. Okay. So this process virtual machine, it's a virtual platform. Okay. So this is created for whom? Individual process, and it will be destroyed once the process will terminate. So this is what process virtual machine. So here in the process virtual machine, it is virtually all operating systems provide a process virtual machine. All operating system, all OS that provide a process virtual machine for each one of the applications running. But the more interesting process virtual machines are those that support binaries compiled on a different instruction set. Remember, the more like process virtual machine that support a binaries compiled on a different instruction set. So this is all about what? Process virtual machine. So next we'll have system virtual machine. A system virtual machine that supports an operating system, which supports an operating system together with many processors, together with what? Many user processors, many user process. When the virtual machine runs under the control of a normal OS, okay, when it is runs under the control of normal operating system and provides a platform independent host. So this will provide what? Platform independent host. It provides platform independent host for a single application, for a single application. The example for this is the example for this, and I told you. Okay. So application virtual machine, or with application virtual machine example for that is JVM. So what is this JVM? Java virtual machine. Java virtual machine is the best example for system virtual machine. It's the best example for what? System virtual machine. So next we'll have the next virtual machine, that is traditional virtual machine. The next virtual machine, which one? Traditional virtual machine. Traditional virtual machine is also called a bare metal. Remember this. This is also called what? Bare metal. This is also called bare metal virtual machine monitor. A, it is a thin software layer that runs directly on the host machine hardware. So traditional, it is directly runs over what? Runs directly on the hardware. So which hardware? It's a host machine hardware. Its main advantage is performance. The main advantage of the traditional virtual machine is performance. And the example for the traditional virtual machine, that is VMware. Okay, I'll just write it over here. Example, VMware is one example. Then we have ES6. Then we have, sorry, then we have Zen. So these all are example for the traditional virtual machine. Okay, so next we have hybrid virtual machine. So what do you mean by hybrid virtual machine? The virtual machine monitor shares the hardware with the existing OS. Okay, it shares the hardware with what? Existing operating system. So, and supports multiple virtual machines. It supports what? Multiple virtual machines. The example for this is VMware Workstation. VMware Workstation is the example for hybrid virtual machine. The last one, that is hosted virtual machine. The virtual machine runs on the top of the existing OS. Okay, this runs what? On the top of the existing operating system, which runs on the top of existing operating system. Which virtual machine it is? It is a hosted virtual machine. So hope you have understood virtual machine and types of the virtual machine. Okay. So move on to next. So here we have the pictorial representation of traditional, hybrid, and hosted virtual machine. Okay. So look at the figure A. Okay. So figure A, here we have the a taxonomy of process virtual machine and system virtual machine. Okay, this is the process and this is the system virtual machine for the same and different ISAs. Okay, so this process virtual machine, this is for same ISA as well as different ISA, and system virtual machine for same ISA and different ISA. ISA, it is a what? It is an interface. Okay, so the three kinds of interface that we have seen in the previous class. One interface is API, another one is ABI, and third one is ISA. Okay, fine. So what happens here? The traditional, hybrid, and hosted are the three classes of virtual machine that we have seen for the system with the same ISA. The ISA which will be same for all the three, which are the three: traditional, hybrid, as well as the hosted. So again, in same ISA, that we have the multi-program and binary optimizer. For different, we have the dynamic transistors and HLL virtual machine, that is high level language virtual machine. And here we have the, for the same ISA, we have traditional virtual machine, hybrid, and hosted, which I have told you just now. Okay, for all the three, we have the same ISA. For different ISA, we have whole system virtual machine and uh, code signed virtual machine. Okay, so this is with respect to the first one, which is what? A taxonomy process and the system virtual machine and the process virtual machine. So hope you understood the first one. So move on to the second. So this is the traditional virtual machine. What is this? The second one, figure B. It is traditional virtual machine. Traditional virtual machine. So we look at the traditional virtual machine. Okay. So here the virtual machine monitor which supports multiple virtual machine. Just look at here. So virtual machine 1. Okay. So on virtual machine n. It means that what? It supports multiple virtual machines and runs directly on the hardware. Okay. So we have this VMM and here we have the hardware. Okay. This runs directly on what? Hardware. Okay, this is what? Traditional virtual machine. So next we have the third one. What is the third one? Third one, that is hybrid virtual machine. Just look at the third one. A hybrid virtual machine, just look at the virtual machine monitor shares the hardware with the host operating system. Okay, so what happens here? The virtual machine monitor which share the hardware. This is the hardware. Okay, so this will be shared by what? Host operating system as well. So here, and it also supports multiple virtual machines. It supports what? Multiple virtual machine. Along with that, it supports the hardware with the host operating system. So this is what? This is the hybrid virtual machine. Okay. Then the last one, just look at this last one. So here we have the last one, that is hosted virtual machine. What happens here? The virtual machine monitor runs under a host host operating system. Here we have the virtual machine monitor. So this virtual machine monitor runs under a host operating system. So runs under what? Host operating system. Again, we have here multiple virtual machines, that is 1 to n. Okay, n number of virtual machines we have. So this is all about traditional, hybrid and hosted virtual machine. So hope you understood this. Move on to the next concept. Okay. So this table, okay, which consists of different virtual machine. Okay. So what it consists? Just look at here. This is a name we have. So name means name of the virtual machine. There are many are there. Okay. We have listed few virtual machines here. Okay. So, and we have the host ISA also. This is host ISA and this is guest ISA. Okay. And here we have the host operating system as well as the guest operating system. I told you about the guest operating system, and these are the companies which have these virtual machines. So what is all about this? Okay, so here it is a non-exhaustive inventory of a system virtual machines. The host ISA, what is this? The host ISA refers to the instruction set of the hardware. What it refers? It refers instruction set of the hardware. The guest ISA, okay, so this is a guest ISA, which refers to the instruction set supported by the virtual machine. What is this? Which is supported by the what? Virtual machine. The next we have the virtual machine could run under a host operating system. Virtual machine could run under what? Host operating system directly on the hardware. So whenever we talk about host operating system which run directly on the hardware, okay, which run directly on the hardware. The virtual machine could run under a host OS directly on the hardware, as I told you, or under a virtual machine monitor. So coming to the guest operating system. So guest operating system, we have many guest operating system with respect to Linux, Solaris. Okay. So guest operating system is the operating system, okay, running under the control of virtual machine. Okay, so this guest operating system which running under the control of what? Virtual machine, which in turn may run under the control of virtual machine monitor as well. So here the host operating system directly run on the hardware, whereas the guest operating system, it run under the control of virtual machine monitor. So these are the companies we have. So these companies have these virtual machines. These all list says the name of the virtual machine. So hope you have understood this. Here, just remember in this particular slide, okay, so what is the difference between host operating system and what is the difference between guest operating system? Okay, so fine. So move on to next. Fine. So hope you have understood the concept. Thank you for watching the video. Please like the video, subscribe the channel and share the video. Thank you so much.